Hello, screen is visible. One second. Hello, screen is visible. Can I reply? Hello.
Visible, sir.
Okay. So I will start with resistive load. Okay. So this is the circuit of the three-phase half-bridge rectifier. Okay. Here, three thyristors are connected. Like this is a three-phase balanced voltage. So balanced voltage means we can write the phasor like this: VA, VB, and VC. Okay. So this waveform only I have drawn here. Let's say this is VA. First one will be VA. This is VA and 120 degree. This is VB and this is VC. Okay. So in three-phase half-bridge rectifier, we are supplying a three-phase balanced AC source to three thyristors, and we are collecting the output at this neutral terminal and this terminal. So here we will get the output voltage. Okay. So these are the phase voltages. So when we can trigger this, let's say this is T1, T2, and T3. So when this phase voltage will be higher than this two, then that will be in forward condition. Okay. So we can see that from here to here, this phase A voltage is higher than B and C. So here to here it will be in forward bias condition. Okay. If we'll move from here, then B is greater than. So here to here, B is in forward bias condition. Similarly, from here to here, the thyristor T3 will be in forward bias. So when it will be forward bias, then only we can trigger that switch. And one main thing is when notation is like this point we are calling as alpha is equal to 0. Okay. This is the reference for alpha. We call at this point as alpha is equal to 0. So we'll measure from alpha from this point. So for phase A, this will be alpha is equal to 0. For B, this point will be alpha is equal to 0. And C, this point will be alpha is equal to 0. Okay. So when we will trigger this T1 at alpha, so alpha means here to here. Let's say this is alpha. Alpha less, and this is 60 degree, 60 degree, and 60 degree. Okay. For one half cycle. So for full cycle, it will be 180 to 360. Full cycle it will be 360 degree. Okay. So let's say alpha less than 30. So here it will be here to here it is how much? 60 degree. So 50% will be how much? 30 degree. So here to here how much? 30 degree. Is it clear up to now? Can anyone reply? Waveform is clear? Hello?
Sir, alpha equal to 30, another is 30 degrees, sir. Alpha equal to 0 and another is 30 degrees.
So this point we are assuming as alpha is equal to 0. This point. So
Okay,
after
sir.
this, if you'll move in this direction, that will be the value of the alpha. Okay. This point we are assuming as alpha is equal to 0. So 30 degree
Down
means,
one, sir.
uh,
Down one.
okay, first I will draw it up equal to alpha equal to 30 degree. Okay. So what will happen if alpha will be equal to 30 degree? So let's say this is the point. So 30 degree means this point, this axis. So here it will come. Okay. Here we are triggering. So it will follow this wave. This is for alpha is equal to 30 degree. It will come up to here. So for B also, what is alpha is equal to 30 degree? This here to here it is 60. So 50% will be 30 degree. So it will come as here. Okay. So it will track the B part from here, and similarly for C, alpha is equal to 30 degree. Okay, so like this. And here waveform will be like this. So alpha is equal to 30 degree means this total here to here it is how much? 60, and here to here it is 30. So this point is reference. So accordingly at here it will pick VA voltage here to here, and similarly here this is VB and this is VC. Is it clear? This waveform for alpha is equal to 30 degree. If we'll go alpha greater than 30, then it will come as discontinuous conduction. Okay. Alpha less than equal to 30, it will be continuous. Is it clear? Otherwise, I will explain again. Right. This point we are assuming as alpha is equal to 0. So from here, if we will measure in this direction, this is alpha is equal to 30 degree. So at 30, if we are triggering T1, then what will happen? VA will appear in the output. Okay. Okay. Clear means, so I'm going to draw for alpha less than 30 degree. So, okay. Alpha less than or equal to 30 degree, what will be the waveform? Okay. So let's say this was 30, let's say this is some value of alpha, less than 30. Okay. So here it will peak from here. Again, it will go here. This one alpha less than 30. Again, this one alpha less than 30. So this will be the waveform VA, VV, and this is VC. Okay. So what will be the average value? This is, so this point we can say as pi by this here will be pi by 3, pi by 6 plus alpha means 30 degree. So 30 degree we are assuming as alpha is equal to 0. Okay, so what will be the angle? What will be the angle here? The 30 plus alpha. Okay, and here it will be how much? So 30 and plus here. How much it will be? Can anyone tell?
2
So
pi by 6 plus alpha, sir.
2 pi by 6 plus alpha. Okay, we'll see. 60 is 60. And here, how much? 30. So 150 plus alpha. So this is 60. This is 60. And this is also, 1 second, 30. Here to here it is 30. So 60 plus 60 plus 30, 150. 150 plus alpha. So 150 means how much? 5 pi by 6. This will be 5 pi by 6 plus alpha. Is it clear? 5 pi by 6 plus alpha. This second point will be 5 by 6 plus alpha here. This is pi by 6 plus alpha. See, this two part is 2 pi by 6, 2 pi by 6, 2 pi by 6, 4 pi by 6, and here to here 1 pi by 6. So 5 pi by 6. Okay. Here to here pi by 6. Is it clear now? Okay. So now we can get the average value. Average we can integrate. So VO average will be, so period is 1 by 2 pi by 3. So in 2 pi it is same. So 3 times it is repeating. So period will be 2 pi by 3 and pi by 6 plus alpha to 5 pi by 6 plus alpha Vm sin omega t d omega t. Okay. So it will be 3 Vm upon 2 pi and sin omega t it will be minus cos omega t, and this is 30 plus alpha and 150 plus alpha. We simplify this one. 1 second. So it will be VO will be 3 Vm phase by 2 pi and it will be cos 30 plus alpha minus cos 150 plus alpha minus cos 150 plus alpha. So can we apply here cos C minus cos D formula? Can you tell what will be the formula of cos C minus cos D? 1 second. This is cos 30 plus alpha. Cos 30 plus alpha is positive minus cos 150 plus alpha. So cos C minus cos D. What will be the formula? Can anyone tell?
Minus 2 sin C sin D, sir.
C plus D by cos C cos D. This is cos D. See cos A plus B. What is the formula? Cos A into cos B minus sin A into sin B. That is the formula. That also we can apply, but for C plus D it will be better. See, we can derive also that formula. Cos A minus B. Okay. So cos A cos B minus sin A sin B. Cos A plus B. Okay. What will the formula? Cos A cos B. This okay. Minus sin A sin B. Is it correct? This formula?
First one, cos A cos B plus sin A sin B, sir. Cos of A minus B.
Okay. This will be minus a plus.
Plus, yes,
And
that
here it
one.
will be minus. Okay. So
Yes, sir.
let's say this is C and this is D. Okay. So if we'll do cos C minus cos D, okay. Let's say this is C and this is D. So if we'll do cos C minus cos D, so what will be the equation? This will cancel. Oh, no. 1 second. Let's say, so then sign part will cancel. Okay. We can directly see, no need to derive this one. Yeah, we can Google search what is the formula. You can also search, I'm searching. 1 second. Just cos C minus cos D formula. 1 second.
We'll get cos alpha, sir. There one.
Cos C minus cos D, you got the formula. That only will apply.
Yes, sir.
What is the formula? Okay, 2 sin C plus D by 2 into sin D minus C by 2. So it will be 3 Vm phase divided by 2 pi into 2 sin C plus D by 2. So C plus D means 150 plus 30, how much? 180. So 180 plus 2 alpha divided by 2 into sin D minus C by 2. So D minus C means how much? Uh, Sin 150 minus 30, how much? 120 by 2. Is it correct? 3 Vm phase divided by 2 pi into 2 sin 90 plus alpha into sin 60. Is it correct? So sin 60 plus means root 3 by 2. So 3 Vm into root 3 divided by 2 pi into cos alpha. Is it clear to all?
Yes, sir.
So final how we can memorize this one? VO average will be 3 VML by 2 pi. So see, root 3 times Vm phase, what it will be? Vm line to line. Okay. So 3 VML upon 2 pi cos alpha. This will be the formula. So here VML means maximum line to line. Is it clear? Like this we can memorize 3 VML upon 2 pi cos alpha. Here L means line to line voltage. So root 3 times maximum phase means that will be line to line. Is it clear?
Yes, sir. Clear.
Okay, okay. So moving to the next. So this is alpha greater than 30. If alpha greater than 30, what will happen? That we are going to analyze. So let's say 30 is here. Okay. I am. What will be the angle here at this point?
90, sir.
Okay. And this is no. For alpha will be 60 here. This is alpha is equal to 0. What will be the
Hmm.
value of alpha here? So this is 30 and this is 30. It will be 60 degree. Alpha will be 60 degree here. Okay. So for alpha is equal to 60 degree, I am going to plot. Okay. So alpha is 60 means alpha greater than 30. So it will start from here. Okay. And it will reach here. Since resistive load, so current will be 0. Current will be 0 means this will stop conducting. And here since this is going negative, so it will not continue the current. So here to here, what will happen? The voltage will be 0. Since current is 0, voltage will be 0. Again here we are firing the T2. T1, T2, T3. So here to here it will conduct up to here pi this angle, and here again it will be waveform like this. Here also it will follow the same sequence. So this is for alpha is equal to 60 degree. It means this is angle is alpha greater than 30. Is this waveform is clear? Otherwise I will explain
Yes, sir.
again. Okay.
Yes, sir.
So see, this is what will be this angle? Pi by 6 plus alpha. This angle. Alpha is 60 degree. Pi by 6 means 30. So 30 plus how much? 60, it is 90. Is it okay?
Sir, that one pi by 3, na sir. Pi by 3 means 60.
No, no, 30 plus alpha we are taking. See, again, you be careful here. This point, this point we are assuming as, see,
Alpha
in
equal to 0.
alpha equal to 0. So that is this angle is 30 degree here to here. In
Ah, okay,
case
sir.
in case of full bridge converter, that will come as 60 degree. Okay. I think
Mm-hmm.
in case of full bridge converter here where we are getting 30 now. In case of full bridge converter, if we'll go for semi converter, there 60 degree will come. Okay. So here
Okay, okay, sir.
it is 30 only. 30 plus 60, this 60, it is 90. Okay. So wait. Okay. 1 second. So pi by 6 to pi by 6 plus alpha to pi. We are getting the average voltage from pi by 6 plus alpha to pi. Why this is 0? Because since this is a resistive load, so it will not conduct, and the output voltage will be 0 since current is 0. Okay. So average voltage we can calculate here also. VO average will be 1 by 2 pi by 3. Okay. And pi by 6 plus alpha to pi Vm sin omega t d omega t. Okay. So it will be 3 Vm upon 2 pi, and it will be minus cos omega t pi by 6 plus alpha to pi. It was usually phase voltage. Okay. So VO average will be 3 Vm phase divided by 2 pi to 1 plus, so cos pi will be minus 1 and minus minus it will be 1. So 1 plus cos 30 plus alpha. Yet clear? So this, then no need to memorize, like if you know the how to derive the formula, so in one line you can derive, just waveform writing is required. So waveform also I will tell you some short tricks. Okay, how to draw the waveform in to analyze. So we can start like this, and for this waveform we can just draw simple triangle. Okay, like this one. Best is like first we draw two lines, so to draw two straight lines, so it will be like this in equidistance. Okay, let's say I'm drawing here and here. Okay, and then triangle we can draw like this and like this. Then what we can do, we can just match like this one, and this will be here, and similarly here it will be matched, and here also it will be matched. So you can draw the basic lines, and here for any angle you can draw. So these lines you can draw for this half-bridge converter. This kind of triangle we will draw, and I will tell in the next class how to draw for full bridge converter. So first we have to make triangle like this. Then you just connect the upper tips and lower tips. So you will get the easily this voltage VA. Then this will be VB, and this will be VC. Is it clear? Any one of you know this trick previously? Can you reply? See, drawing the waveform will be the difficult part. Like in case of three phase, like first sine wave drawing only it will be difficult. So if this short trick you will know, first you can easily draw the dotted line. After that you can draw any waveform. Is it clear?
Sir, for this we have to draw only phase voltage, sir.
For this is half wave rectifier. So phase voltage only itself will be enough for here. In
For
case of
full bridge,
full bridge, I will
it will
show.
be line to line.
That will be line to line. So one relation is there in line and phase voltage. A 30-degree shift will be there. Okay, that I will show with MATLAB plotting also. like I will take three voltages. Okay, three phase voltages first we will plot, and after that three voltages we will subtract that voltages in coding form, and then we will see the line voltage. So there we will observe that the line voltage, that leading angle is there, na, that will come in that waveform. Okay. So before starting the full bridge rectifier, I will explain that relation between phase and line voltage. So that we will see with phasor and as well as the waveform also. Okay. Then it will be more clear. In half wave rectifier, only phase voltage. See here we are connecting phase voltage. So output is connecting between this and this point. Okay. So across the output only phase voltage is appearing. Is it clear?
Yes, sir. Clear, sir.
Okay. Okay. If you solve some previous year question, na, so like good questions are there based on the full bridge rectifiers, like then it will be more clear. Like my target is I will discuss all the previous year questions, whatever are based on the rectifiers. Most of them I have already covered. Single phase I have covered. So all the three phase questions, that also I will cover with waveform analysis. Okay. So this formula is clear. Is it okay? Average voltage for alpha greater than 30 resistive load. Is it clear to all? So this we have to memorize. If you memorize, okay, yeah, okay. Otherwise, you can just one line. You can draw the waveform and you can derive this equation. Should I move to the next part?
Yes, sir.
Okay. So RL load alpha less than 30. Okay. If RL load also will be there and alpha is less than 30 degree, then also the output voltage will be continuous. Same. Let's say alpha less than 30. I'm going to draw the waveform. So it will be same only. Let's say this is alpha less than 30. So it will go up to here. Again it will here. Again it will here. So already this type of expression we have done. Pi by 6 plus alpha to 5 by 6 plus 5 pi by 6 plus alpha. This will be the waveform. Since alpha less than 30 degree, for any case, either it will be R load or RL load, this will be a continuous conduction. Okay. So what will be the average voltage in this case? Same. Already we have derived. VO average will be 3 VML upon 2 pi cos alpha. Here VML is the maximum line to line voltage. Okay. Is it clear? So for RL load also, if alpha will be less than 30 degree, formula will be same. 3 VML upon 2 pi cos alpha. Should I move to the next part? Is it clear?
Sir, for next one also same formula, sir.
Uh,
For RL, alpha is greater than 30 degrees.
no, there it will, there also it will be same only. We will see. Only waveform will be different, formula will be same. So
Okay, okay.
only for discontinuous conduction where voltage will become zero, there only we are getting this formula. Okay. So this condition will come either when we are using freewheeling diode. So if we use freewheeling diode in case of continuous conduction, then this will come. Otherwise, in case of purely resistive load with the discontinuous conduction. Is it clear? All the case we'll see one by one. Okay. So for this case, this is the formula. Now alpha RL load only alpha greater than 30. What will happen? Okay. So see, since RL load is there and current will be, we are assuming let's say constant current and continuous ripple free current. I know. Okay. So what will happen? Let's say I'm triggering at alpha is equal to here. Same alpha is equal to 60 degree. Okay. So what will happen? It will conduct up to here. Since inductive current is there, so that current will follow this path only. Initially current is following through this one. So since other thyristors are not triggered, so before other thyristor will trigger, till then it will follow this path only. So this path only means this negative portion will also come in the output. Is it clear? See,
Yes, sir.
alpha is equal to 60, here to here alpha is equal to 60. So it will go. Second switch will trigger here. But in case of resistive load, what was happening? The voltage was becoming zero. Okay, at here voltage was becoming zero. But in case of inductive load, Since the current is constant, it will force this T1 to conduct, and if T1 is conducting, this VA will appear at output. So this yellow color waveform will across output. Again, it will flow here and it will flow through here. Okay. So if you'll see the here, this is pi by 6 plus alpha, and here it is 5 pi by 6 plus alpha. Okay. So output voltage expression will be same. Same VO average will be 1 upon 2 pi by 3 pi by 6 plus alpha to 5 pi by 6 plus alpha Vm sin omega t d omega t. So this will become 3 VML upon 2 pi cos alpha. Is it clear? Like already one have said, like this will be same like for RL load also. So only where we are getting the different, we are getting different in case of resistive load alpha less than alpha greater than 30 degree. Okay, resistive load alpha greater than 30 degree, we are getting this formula, and for other cases we are getting this 3 VML upon 2 pi cos alpha. Is it clear?
Yes, sir.
Okay, okay. So now I am moving to the freewheeling diode case. There we will do the Fourier analysis of the input source current. So same RL load I am doing analysis for alpha less than 30 degree, and output current I am assuming as constant current. Okay, this is RL load and ripple free constant current. So alpha less than 30 degree first I am assuming. Let's say this is alpha. So waveform will be like this. Here it will follow through here, and again it will here. Okay. So what is this angle? Pi by 6 plus alpha, and this angle is 5 pi by 6 plus alpha, and here to here it will be 2 pi. What will be the average voltage? Average voltage will be same, since output voltage is continuous. So it will be 3 VML upon 2 pi cos alpha. Voltage equation will be same. See, freewheeling diode, when it will conduct? When alpha will greater than 30 degree, then only this diode will conduct. Is it clear? When this voltage will become negative, if output voltage will become negative, then this diode will become forward bias, and then this current will flow through diode. But here alpha is less than 30 degree, output voltage is always positive, so freewheeling diode will not conduct. Is it clear?
It is also continuous conduction, sir.
Yes, continuous conduction with RL load. See, if question will be there, RL load continuous conduction with freewheeling diode or without freewheeling diode, because this freewheeling diode is not coming into the picture. Okay, it will come into the picture only when alpha will be greater than 30 degree. So if some numerical question will be there where alpha will be less than 30 degree given, okay, so either the circuit will be with freewheeling diode or without freewheeling diode, because this is not conducting here. Okay, so same analysis will be there. Is it clear? Is it clear?
Yes, sir. Clear, sir.
Okay, okay. So if we'll see the source current, phase A current, IA, this is T1, T2, T3. So source current, since output current is constant, so source current will be, it will flow from this here to here, which thing is conducting? T1 is conducting, again here T2 is conducting, and remaining T3 is conducting. So I'm going to draw the phase A current. So phase A current will be this one. Again it will come after 2 pi. Is it clear? This is the current of phase A. So what will be the RMS current? Phase RMS current, IA RMS. IS RMS we can say, source RMS current. So it will be I naught into, what is this angle? 5 pi by 6 plus alpha minus pi by 6 plus alpha. So it will be how much? This is 150. So
2 pi
120.
by 3, sir.
120 divided by 360. So it will be I naught divided by root 3. RMS value of the source current will be I naught divided by root 3. Is it clear? Is it clear? Otherwise, I will explain again. See, total duration is 120 degree. This is 150 plus alpha. This is 30 plus alpha. So 150 plus alpha minus 30 plus alpha. So duration is 120. What is the RMS? The magnitude into the conducting period divided by the total period. Okay. So it will be I naught by 3. If average current will be asked, then that will be I naught by 3. It will be IS average. Is it clear?
Yes, sir.
Okay. So if they will ask either thyristor RMS current or average current or source RMS current or average current, that will be same here. Okay. Since current is flowing in this only, so whatever the thyristor or RMS will be, that same will be the flowing through the source. So if in numerical they will ask either source current or thyristor current, answer will be same. Okay.
So that
Now,
one I not by 3 na sir. ISRM.
I naught divided by root 3. See this magnitude here to here, it is I naught. Okay. Since
Hmm.
output current constant I naught, so pi by 6 plus alpha to 5 pi by 6 plus alpha, this magnitude will be I naught only. Okay. Is it clear?
Yes, sir. Here in down you wrote I not by 3 equal to ISRMS.
IS average.
IS average. Okay, okay, sir.
This is average I have written. Average means a square root will not be there, and RMS means a square root will be there. Is it clear?
Okay, okay, sir. Clear, sir.
Okay. 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 So moving to the next part, like alpha greater than 30, what will happen? So alpha greater than 30, first we'll draw the waveform. So let's say I am for 60 only I am drawing here. So it will start here. Okay. Second. So 1 second. So what will happen here? After here voltage is going negative. Okay. So this free will, if it is negative here, then this will become forward base. If it will become forward base, then forced conduction through this thyristor will not happen. This current will flow in this path only. So here to here, output voltage will be 0. Again here, this will conduct, and here to here, voltage will be 0. Similarly, so this case is, this output voltage is looking similar to the resistive load. Is it same?
Yes, sir.
Okay. So this part, our T1 is conducting, here to here T2 is conducting, and here to here T3 is conducting, and freewheeling diode is conducting here. This zero voltage part, here FD is conducting, here also FD is conducting, and here also FD is conducting. Okay. So we can draw the waveform here also. First I am going to draw the source current IS T1, and here to here. So this angle will be pi, and this one is pi by 6 plus alpha. Is it clear? What will be the average voltage here? Already we have derived. VO average will be 3 Vm phase divided by 2 pi 1 plus cos 30 plus alpha. This only was there. Average voltage. Already we have derived for resistive load case. Same kind of waveform was there. Is it clear?
Yes, sir.
Okay. Okay. So what will the RMS current here? IS RMS will be is pi minus 130. So it will be 180 minus 130 plus alpha divided by 360 into I naught. So it will be I naught into 150 minus alpha divided by 360. Is it clear? Source RMS current. Can anyone reply?
Yes, sir.
Okay. And what will be the freewheeling diode current RMS? Can you observe and tell? IFD RMS. For how much duration it is conducting in 360 degree?
30 degrees, sir.
No, see, here to
Uh,
here, it is our cycle is starting from here. It is
60, sir.
it is ending where?
No.
This is sine wave starting here, 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 here. It is ending here. Okay, here it is ending 360 degree. So if you'll see, this is how much? This is how much? This is how much? So what will this value? Here to here alpha. This point is pi by 6 plus alpha, and this is what? Pi by 6. What is this value? Pi by 3. Hmm? So how much will be the duration? Pi by 6 plus alpha minus pi by 3. This will be the conducted duration for 1 here. So this will be 3 times. 3 into this one. Is it clear? With these 2 points I am assuming here to here. 1 second. We'll draw the waveform. So one is this point, another is this point. Okay. This point is pi by 6 plus alpha, and this point how much? Pi by 3. Is it clear?
Yes, sir. For 3 times into
Uh,
3.
it will be 3 times divided by 360. Okay.
Okay.
So this will into multiplied into I naught. That will be the IFD RMS. So this question also can be asked. What will be the RMS current of the freewheeling diode? Okay. So in 360 degree it is 3 times it is conducting. Okay. Otherwise 120 120 we can also say. So what will be the angle divided by 120? Same only. This will divided by 360. So 120. In 120 it is conducting for this much duration. Okay. So pi by 6 minus pi by 3 how much? So it will be pi by 6 minus pi by 3 plus alpha divided by 120 into I naught. So this will be freewheeling diode RMS current. Is it clear? It will
Alpha
be
minus pi by 6 by 120.
alpha minus pi by 6. Okay. So alpha minus pi by 6 divided by 120 into I naught.
Why not?
Okay. So see, since alpha is greater than 30 degree, so this is correct only. This will come always positive. Pi by 6 means 30 degree. So alpha minus 30 divided by 120. It is correct only because our alpha is greater than 30 degree. Okay.
Okay, okay,
This is
okay.
correct only. So like this you have to analyze. Okay. This kind of 2 marks question can be asked. Like what will be the freewheeling diode RMS current or thyristor RMS current. Okay. First you have to see the type of load, then value of alpha. Alpha greater than 30, less than 30, you have to do the analysis. So now I'm moving to the source current Fourier analysis. Is it clear up to now?
Clear, sir.
Okay. So this will be the main part. Okay. So for alpha less than 30 degree, first we will see the waveform. What was the waveform? So waveform was pi by 6 plus alpha to 5 pi by 6 plus alpha. Again, it was a repeating waveform. Okay. So I'm going to draw the same waveform. This is pi by 6 plus alpha. Here it is 5 pi by 6 plus alpha. Again here 2 pi, and this distance will be same here. It will be repeated. Okay. If we'll go in back side, minus side, so then also if you'll see, this is let's say minus 2 pi will be there. Again here it will be the same waveform. Okay. So here to here distance and here to here distance, is it will be same? Will it be same? Since it's a repeated if, it should be same only. Is it okay? This point to this point distance. Okay. So see, this waveform is neither even nor odd. So what I'm going to do, I'm going to make this waveform as a even waveform. So how we can make this point, if this zero axis will be at this point,
Shifted, sir, that one.
that only we have to shift this waveform in this direction such that this point will come here. Okay. So by how much angle we can shift, that only we have to calculate. Okay. So what will be this line? First we have to know with respect to x-axis what is the position of this line. So first we will see this duration, how much. So duration is how much? 120 degree. Okay, this duration is 120 degree. Okay. So if we'll subtract 60 degree from this one, this point, 5 pi by 6 plus alpha, 5 pi by 6 plus alpha, how much? 150 plus alpha. Okay. Minus 60 if I will subtract, then we will get this line. Is it clear? So here to here it is 120 degree. Okay. Here to here it is 120 degree. So here to here it is 60 degree. So from this point, if I will subtract 60 degree, then I will get this point. Is it clear?
Yes, sir.
Okay. So this point will be 90 plus alpha. This point will be 90 plus alpha. From 0 to here, this axis will be 90 plus alpha. So if we will shift this side by 90 plus alpha, it will become a waveform like this. So then this will become a waveform like this. So this will be some. So what will be this value? What will be this point? So if we'll do this minus 90 plus alpha. So this minus 90 plus alpha. So this is 150 plus alpha minus 90 plus alpha. How much? 60
60, sir.
degree.
5 by
Okay,
6.
this will be 60
5 by
degree,
3.
and this will be something no need to do, no need to take care. So this will be 2 pi, and this waveform will come at 2 pi. Okay, here. So the formula is, if we are doing even symmetry, so if this waveform will see x minus t is equal to xt. Okay, this is following the even symmetry. So even symmetry, already I have told the trick how we can do the analysis. If either even or odd, it will follow. So an will be calculated as 4 by t, 0 to t by 2, xt cos n omega t dt. This is the short trick. Like normally we'll calculate 2 by t, 0 to t, but if even symmetry and half wave symmetry will be there, so in that case we will use this short trick. Okay. So our waveform is there, that is 0 to, this is how much? Pi by 6, pi by 3. So this is pi by 3. 1 second. This is pi by 3. So here you can put 4 divided by 2 pi, 0 to pi by 3. Xt is what? I naught cos n omega is equal to 2 pi divided by 2 pi. Since the period is 2 pi. Okay, so omega will be 1. So cos nt dt. It will be 2 I naught upon n pi. Okay. And what will be the this integral? So sine integral differentiation is cos, so cos will be sine. So sine nt dt. Is it clear up to now? Otherwise, I will explain again.
Sin n, sir. Sin n t.
Sine nt dt. Okay.
Integral
So 0
limits are
to
0 to
pi
5 by
pi by
3.
3. Okay.
Yes.
So it will be 2 I naught upon n pi sine n pi by 3.
మౌని వెళ్ళరా
So this will be the value. A.
ఫోరేమంటున్నావు
Bn will be 0. Bn will be 0 since it is following even symmetry. So what will be the final expression? An cos of n omega t. X of t will be sigma n is equal to 1 to infinity an cos n omega t. Okay.
Cover బాగాలేదు
So ISN will be n already we know 2 I naught upon n pi sin n pi by 3. So it will be 2 I naught upon n pi
50 రూపాయల
sin n pi by 3. And here cos, what will be the value?
బాగోలేదండి
See, it will be cos n omega t. But we have to calculate for the shifted waveform. Okay.
నువ్వు అయితే ఎక్కువ వేసేస్తున్నావు లేదా తక్కువ వేస్తున్నావు
Is
సరిపోతే
it clear up to now? So we have calculated for this one, but we have to write the Fourier for this one. So what will be the equation? Equation will be 2 I naught upon n pi sin n pi by 3 cos n omega t minus n pi by 2 minus n alpha. Is it clear?
Yes, sir.
Okay. So this will be 2 I naught upon n pi sin n pi by 3, and here it will be sin n omega t minus n alpha. This you can verify. Okay. Because pi by 2 factor is there, cos will become sin. Is it clear? So this will be the final Fourier waveform. Okay. If we'll see the fundamental, what will happen? IS1 will be 2 I naught upon n, 2 I naught upon pi into sin pi by 3.
చెప్పలేదు మనకి లైఫ్
So
ఎవరి జోలికి
So what will be this value? Pi by 3?
ఇప్పుడు ఎవరి జోలికి నేను
Root 3 by 2.
ఇప్పుడు ఎవరి జోలికి వెళ్ళినా ఎవరి జోలికి వెళ్ళిపోతేనే మనం నచ్చం
Okay. So 2 I naught upon pi into root 3 by 2, and here it will be divided by root 2.
లోపల చేసేది
So it will be IS1. IS1 will be
Right into sir that divided by.
Okay, you can ask. Anyone have? Why is this coming? Hello. Okay.
Sir, here
you can
denominator root 2 came na, sir.
సారీ సార్
Huh.
బై మిస్టేక్ మైక్
It's okay. It's okay. It's okay. So where is the mistake? Can you point out again?
Sir, IS1 equal to 2 I naught by root 2 by pi, sir. IS1.
IS1 will be 2 I naught n we are putting at 1. So 2 this is amplitude only. So it should be root 2 here for RMS. Okay.
Okay, sir.
RMS means should be divided by root 2. If like in 2022 only, they have asked amplitude. Okay. So if they will ask amplitude, then we should not divide it by root 2. Okay. In that case, this magnitude only we should write. Amplitude means peak value. If fundamental current will be asked, nothing they are asking about amplitude or anything. So then we have to divide it by root 2. Okay. So this value I am dividing by root 2. So 2 I naught divided by root 2 into pi and sine 60. So sine 60 will be root 3 by 2. Is it clear? So fundamental will be root 3 by 2 I naught upon pi. So now we can verify this formula by making the power balance equation. Okay. Like how to memorize this one, that I will tell. So let's say I'm memorizing, I am equating the power. Okay. So we can say that root 3 into Vs IS1 cos alpha. Let's say line to line current, line to line voltage I am doing. It should be V naught I naught. Okay. And what is V naught? V naught is equal to 3 VML upon pi into cos alpha into I naught. This is the formula. Is it clear up to now? So what we can write here? What is this maximum? Maximum will be 3 into Vs into root 3. Is it clear?
Yes, sir. By pi into cos alpha.
By pi into cos alpha. 1 second. I think here it is 2 VML, 3 VML only. Somewhere we are doing mistake. 3 Vs. It should equate with this also. 1 second. Okay.
3 Vm
So
by 2 pi, sir. 3 VML by 2 pi.
3 VML. So this is maximum line to line. So maximum line to line. So what will be the RMS?
Sir, here 3 VML by 2 pi cos alpha I naught, no, sir.
Okay, okay,
Average.
okay. 1 second, 1 second. Okay, this was the mistake. Now one by one we will do. So this side what I am taking, this is line to line RMS voltage. This is three phase power equation, you know. 3 root 3 into VS RMS, line to line RMS into phase current into cos alpha. This equation already you know. Real power equation, root 3 into VS into IS. Here VS is the line to line voltage. Is it clear, this equation?
Oh, yes, sir.
Okay. So here we will try to make into VS form. Okay. So this is maximum line to line. So first we will do what is maximum line to line means root 3 times maximum source. Hmm? Source maximum, phase maximum. So root 3, 3 into root 3 into BPH max. Is it correct?
Oh, yes, sir.
1 second. And cos alpha I naught is there. It should be if I want 1 second, 1 second. Something mistake I have done. I should not go in phase. I should do in line only because here line is there. Okay. So better to do in line only. So line maximum is there. What will be the line RMS? RMS will be maximum by root 2. So maximum is RMS into root 2. That is clear. So 3 into VS RMS into root 2. Is it clear? By 2 pi into cos alpha into I naught. Is it clear now? See, this maximum line to line was there, that I have converted into RMS into root 2. No. Is it clear now? RMS is equal to maximum by root 2. So maximum will be RMS into root 2. Is it clear?
Okay, sir.
See, now we will get. So root 2, this will here, root 2 times, okay, and root 3 will be this root 3 times. And VS will cancel, RMS line to line voltage. So IS1 will be under root, this one not 3 by 2 only we got. So under root 3 by 2 into I naught. Is it clear? Is it clear? Cos alpha will cancel. Otherwise, I will explain again once more. Is it clear?
Sir, clear, sir. Clear, sir.
Okay. So this step you should know. Simply, if you are knowing this equation, okay, this power balance, if you are forgetting this, whether this will be root 3 by 2 or root 2 by 3, sometime confusion will come during the exam. Okay. So if you are getting any confusion and this formula you know, then you should apply the power balance equation. Then you will get this one. Okay.
Sir, LHS is common for all configurations, sir.
No.
Only
See,
RHS.
LHS will be real power, P real. Okay. So in single phase, this is three phase formula. For single phase,
Yes, sir.
it will be VS into IS1 into whatever will be the. So one thing you have to remember, like for like what will be the displacement factor. So what is the displacement factor here? Displacement factor is cos alpha. Okay. This you have to remember. Only thing you have to remember is cos alpha. Like you can, I will draw a table in last class of this one. So there I will write all the formula all together. Then I will tell the hint how to memorize all. Okay. So if you know this displacement factor, then only you can apply this formula. Okay. If you don't know this one, if this displacement factor will be something else for this, then if you apply like semi converter, what is the displacement factor? That is cos alpha by 2. Single phase semi converter. Okay. So this displacement factor you should know to apply this power balance. Is it clear?
Yes, sir. Clear, sir.
Okay. So now I'm moving to the next type, like alpha greater than 30 degree. So in this case also we have already drawn the source current, so that I'm going to draw here. Okay, so this was pi by 6 plus alpha, and this was pi. Here it was 2 pi. Again, same waveform was happening. Was it the same? You check your notes. Let's say it minus 2 pi. So here also we will do the shifting. Okay. Is the waveform is correct? Can anyone tell? So here also we have to find this midpoint. What will be this midpoint? Okay. What will be this here to here? This will be 150 minus alpha. Okay. So what will be this point value? Value of this point? Can anyone tell? This is 180 minus 150 minus alpha divided by 2. This will be this point value from 0 to here. Is it clear to all? Can anyone reply?
Yes, sir.
Okay.
18360 minus 750.
See, here to here, this is 180 minus 30 plus alpha. So it will be 150 minus alpha. Already we have done this one. So since here to here it is 150 minus alpha, so what will be the half part? Half part will be 150 minus alpha by 2, and that I am subtracting from pi. So here to here pi, if pi I am subtracting 150 minus alpha by 2, so this will be the this point value.
Sir,
Okay.
210 minus alpha by 2,
So it will
sir.
be 210 minus, no, it
Alpha
will
by
210
2.
plus alpha by 2.
Okay, okay, please. Okay, sir.
It will plus na? Okay. 210 plus alpha by 2. Is it clear? So after the shifting, the waveform will be like this. What will be this value? So from this we'll subtract this value. 210 minus 210 plus alpha by 2. So 180 minus 210 plus alpha divided by 2. How much it will be? It will be 360 minus 210. How much? 150. 150 minus alpha by 2. So this point will be 150 minus alpha by 2. Is it clear?
Yes, sir.
Okay. So what we have done, we have shifted the waveform by 210 plus alpha by 2 in this direction. Then it will become even. X minus t is equal to xt. Okay. And this point we are getting 150 minus alpha by 2. So we can do the integral in same way. So an will be 4 divided by 2 pi 0 to 150 minus alpha by 2. So this is 150 minus alpha by 2 I naught cos nt dt. Here also time period is 2 pi, so omega will be 1. Okay. So 4 I naught upon, okay, 2 I naught upon n pi. Here it will be minus, no, it will plus only, plus sine nt 0 to 150 minus alpha by 2. Is it clear? This will be the n value. So this week I am going to write in terms of 90. Okay. So in terms of 90, we can write as 90 minus alpha plus 30 by 2. We will get this value only 150 minus alpha.
Yes, sir. Same, sir.
Okay. So this we can write. So 90 minus this means cos. Okay. So we can write 2 I naught upon n pi cos n into alpha plus 30 by 2. Will it be the same? N value 90 minus theta cos theta all sine tan cos. Is it clear? I think it will not be same for all. For fundamental, I think it will be like this. Okay, one second. We can write this equation directly. where is that equation? Sine n into 90 minus alpha plus 30 divided by 2. So for n is equal to 1, it will be cos alpha. So for n, fundamental one I am writing. So for fundamental it will be sine alpha plus 30 by cos alpha plus 30 by 2. Okay. So n will be cos n into alpha plus 30 by 2. For different n, I think it will be different. If n is equal to 2, then it will be 180. This factor will be 180. Okay. For even harmonic, it will be different. For odd harmonic, it will be different. So these are only for odd harmonic, I think. Okay. Is it clear? So our focus will be on fundamental only. Is it clear? N value cos n into alpha plus 30 by 2. Is it clear to
Yes,
all?
sir.
Okay. So is of n I am going to write. It will be here. Some terms I have left 2 I naught upon n pi, 2 I naught upon n pi. So it will be 2 I naught upon n pi cos n into alpha plus 30 by 2 into sine term here n cos n omega t. So cos n omega t. Okay. So this is I'm writing. So this is for shifted waveform. N omega t for shifted waveform. But we have to write for this one. So that will be shifted. So here we can write this is for shifted. So this is for actual. Okay. So actual equation will be 2 I naught upon n pi cos n into alpha plus 30 by 2 into cos. So shifting will be n omega t. Here what was the value? 210 plus alpha by 2. Okay. So shifting was 210 plus alpha by 2. So this we can write in terms of any 90. 90. Okay. 1 second. Is it possible to make it in terms of 90 shifting? 210 plus alpha. So 90 plus alpha plus 30 by 2 we can write. Hmm?
Yes, sir.
So it will be minus 90 minus alpha plus 30 by 2. Is it clear? Hello? Is it clear now?
Yes, sir. Yes, sir.
So it will be same as previous. So it will be 2 I naught upon n pi cos n into alpha plus 30 by 2. Okay. Into sine n omega t minus n into alpha plus 30 by 2. This will be the equation. So I'm going to write on the next page. ISN will be equal to 2 I naught upon n pi. Okay. And cos n into alpha plus 30 by 2 cos n into alpha plus 30 by 2 into sine n omega t minus n into alpha plus 30 by 2. So what will be the displacement factor? Can anyone tell? What will be the displacement factor for this case? See this shifting. So this will be the displacement factor. So CDF will be displacement factor will be cos alpha plus 30 by 2. Is it correct? What will be IS1? IS1 maximum will be 2 I naught upon pi cos. This will be alpha plus 30 by 2. Is it clear? Can anyone reply?
Mm-hmm.
Nobody
Yes,
able?
sir.
So this will be. You can ask again. I will explain. If any doubt will be there, I will explain. So this we have to memorize. Okay, displacement factor will be, since it is shifting by alpha plus 30 by 2, so if we'll put n is equal to 1, the fundamental sine wave, it will shift, like this is fundamental voltage wave, so sine wave will be shifted by alpha plus 30 by 2. This is the current wave. This is the fundamental voltage. So 50 hertz, like current, fundamental current will shift by alpha plus 30 by 2. So displacement factor will be cosine of alpha plus 30 by 2. And fundamental source current is this one. What is the RMS value of the source current? IS RMS will be 150 minus alpha by 360 into I naught. Is it clear? So this we know, fundamental we know this one. So this is the amplitude. What will the RMS? RMS will
By
be
root 2.
root 2 I naught upon pi cos
Okay.
alpha plus 30 by 2. IS1 RMS. Is it clear to all?
Yes, sir. Yes, sir.
Okay. So based on this, some questions I have taken. Should we solve that questions?
Yes,
You
sir.
are
One.
okay. Okay. So one question we will take. So this is question, like normal question, alpha is 15 degrees, so less than 30 only. Here alpha is less than 30. Okay. So what will be CDF, current distortion factor? First IS RMS, we'll go one by one. Okay. Let's say output current is 10, 10 ampere. Okay. What is the IS RMS? Formula already I have taken. IS RMS will be I naught by root 3. Is it correct? 10 by root 3. What will be IS1 RMS? Will be I naught into I naught by pi into root 3 by 2. This one, Lila? Is it correct? We'll go to back. For first case, I have already told this formula. Less than 30. So this fundamental source current root 3 by 2 into I naught by pi, and source current will be I naught by root 3. Is it correct? Can anyone reply? Hello? Am I audible?
Yes, sir. Audible, sir.
Okay. See, so this case question is from this case. Okay. So this root 3 by 2 only was there, no? 1 second. Root 3 by 2 into I naught by pi. So we'll calculate fast. So root 3 by 2 into I naught by pi. Okay. So 10 by pi into root 3 by 2. This we can calculate later. Okay. So what will be IS1 by IS? Okay. So here the displacement factor will be cos alpha equal to cos 15. Okay. IS1 by IS. What will be this factor? So IS1 is I naught by pi into root 3 by 2. So I naught by pi into root 3 by 2. And what is IS? IS is I naught by root 3. So what will be this value? I naught will cancel. So it will be 3 by pi root 2. Is it correct? Can anyone reply? Is this value is correct?
Yes, sir. Correct, sir.
So input power factor will be IS1 by IS into cos alpha. So 3 by pi root 2 into cos of 15. This we have to calculate. So 3 by pi into root 2 into cos 15. How much? 0.6522. We are getting 0.6522. So this is the input power factor. This is the input power factor. THD also we can calculate. So THD is 1 by distortion factor whole is 1 second. This mistake I have done. THD will be 1 by distortion factor whole square minus 1. So pi into root 2 by 3 whole square minus 1. This will be the THD. Can anyone calculate this value? I'm also calculating. So pi into root 2 divided by 3. whole square minus 1. PhD we are getting more than 100%. This case will also come sometime. So 109.2%. Okay, is it clear?
That my THD will come, sir.
Sometime it is coming. Like some inverter also in MATLAB also I have analyzed. Some term is there like more than 100% we are getting. Like it means the fundamental value is very less. Okay,
Mhm.
other harmonics are more. See, since this here we are getting DC value also, na DC output side. In output DC also we are getting average like other. If we'll see the other quasi square and other waveform, their DC value will be 0. Okay. In MATLAB also I have analyzed this like sinusoidal PWM technique. Sometime I have applied. There we are getting THD more than 100%. See, this distortion factor is correct only 3 by pi root 2. So 1 by df whole square minus 1, this only is the formula. So pi into root 2, actually no, pi into root 2 divided by 3 whole square minus 1. So 109.2%. This is correct only. Okay. It will, all of you have MATLAB software?
No, sir.
Okay. We can try after enrolling in some master program. Okay. This thing if you will analyze with MATLAB, after GATE exam you can try these things. Okay. Like before, after writing the GATE exam, some time will be there for interview, master's interview and all. Okay, between those times, you can crack version also MATLAB we can get. Otherwise, LTS Spice one software is there. So if you'll do practice in those softwares, so that will be add on to your like in your interview. If you have these skills also, then selection chances will be more for MS degree. Okay. Like if you are get, let's say you are getting 2000 rank, 2500 rank. With that rank also you can get top IIT like IIT Madras, IIT Bombay, IC Bangalore, IIT Delhi. These IITs also you can get for MS program, not for MTech. But MS and MTech placements are equivalent. Okay, that people don't know. So you should whatever rank you will get, you should utilize that rank. Is it clear?
Sir.
Okay. Okay. So next class, I will discuss some questions related to this, and I will start the line voltage relation between line voltage and phase voltage analysis. That I will show with MATLAB waveform. Again, I will draw that waveform also. And for full bridge converter, similarly, we will do the Fourier analysis. Okay. Okay. So thank you all.
Sir,
Yes, you can
sir,
ask.
sir, for alpha greater than 30 degrees, we can also do that power balance equation, sir.
I will do. Okay. Wait. If you want, now only I will do. So,
Okay, sir.
okay, if you all of you are okay, I will do that. So alpha greater than 30-degree power balance equation. So root 3 into Vs into IS1 into cos alpha plus 30 by 2. What is the displacement factor there? This we have to remember. This we have to remember. Okay. Is it clear?
Yes, sir.
Is equal to V naught I naught. So what is V naught? V naught is equal to 3 Vm phase by 2 pi 1 plus cos alpha plus 30. This only was there for that case.
Yes, sir.
Okay. So let's say here I am doing in phase only. Okay. 3 into V phase. So power equation, 3 into Vs phase. Let's say that 3 V phase I phase cos alpha or root 3 VL I phase cos alpha. This is the power equation. All of you know this one. Basics. Okay. VI conjugate, if you apply this information you get. So this is also a power equation. There, if I am taking phase voltage, okay. So phase voltage 3 into V phase into IS1 into cos alpha should be V naught. So here also this is V phase. Okay. So V phase maximum, what will be the RMS? RMS is equal to maximum by root 2. So maximum is equal to root 2 into RMS. So 3 into root 2 into Vs phase RMS divided by 2 pi. Is it correct? Is it correct? Can anyone
Sir,
reply?
by 2 how, sir? Cos alpha plus 30 only, no, sir?
Okay. 1 second. Cos alpha plus 30. Okay. So this we can write in this form. 1 plus cos alpha plus cos theta is equal to 2 cos square theta by 2 minus 1, like that.
Yes, sir.
So this we can write as 2 cos square alpha plus 30 by 2. Is it correct? I think it will be correct only.
Sir. Got
And
it, got it.
3 will cancel. Okay.
Yes, sir.
Vs phase will cancel.
Hmm.
And this cos alpha plus 30 by 2, one time it will cancel.
One time cancel. Yes, sir.
Okay. Another thing we are getting cancel anything. So IS1 will be something we are missing anywhere. Second.
RS side cos alpha, sir, that one.
Which one? IS1 will be. So this will be cos alpha plus 30 by 2. Cos alpha plus 30 by 2. Is it okay? And here I not. Okay. So how much we got there? For fundamental, how much we got? 2 I naught upon pi cos alpha plus 30 by 2. So root 2 I naught upon pi cos alpha plus 30 by 2. Okay. 1 second. So this 2 we are getting extra one. No.
Here 2, that one to cancel now, sir.
2
2
okay.
cancel.
2 will cancel because this is 2 will come here. I have written here. Okay. It should come here.
Yes, sir.
So 2 will cancel. I naught root 2 I naught upon pi. I think it is correct now. Huh? IS1 will be root 2 I naught upon pi cos alpha plus 30 by 2. Is it clear? I think it is
Yes,
clear.
sir.
Okay, so like this way, so how we can you can categorize, you write step by step, like single phase, all you can write, and displacement factor you have to memorize. For all, you can write the displacement factor. Okay, if you memorize the displacement factor for all, then you can apply this power balance equation and you can derive the IS1 for that particular converter. Is it clear?
Yes, sir. Clear, sir.
Okay. So thank you all. Next class I will discuss more questions and I will start the full bridge converter. Okay.
Yes, sir.
Thank you all.